Hi and welcome back to Miss Riley's Maths videos. This is an algebra video. It's about changing the subject of a formula. These are also known as literal equations. It's found on the Junior Cert Higher Level course and the Leaving Cert Ordinary Level course. And what's happening here is that we are given various formulas or things that look like they might be formulas, so equations with letters in them, and we have to change these around so that the letter in the box, is how I've put it here, is the subject of the formula. In other words, that when you end up with your new formula, the letter in the box is by itself on one side. It's isolated on one side. So what I suggest you do is that you stop the video and you give these a go and see how far you get, and then start the video again and watch the solutions. If you get stuck on a particular question, you could try the next one, or you could stop and watch up to that point. So try and use this as a revision type of class, where you're trying these first and then you're looking to see how I work them through. So stop and start as you need to do so. Okay, so they're here. I'm going to start them in a moment, so this is your chance to stop. Okay, so I'm going to work through the solutions now. So let's start with the first one. We've got a minus 2b is equal to 6. A minus 2b is equal to 6, and we're trying to make a the subject of the formula. Now what I often say to my classes is that this is BIMDAS in reverse. So this was BIMDAS, brackets, indices, multiplication, division, addition and subtraction. That's what BIMDAS is, and when we're in first year we learn that's how you operate on numbers. Normally we go this way, but for these we're going to go this way. We're going to start with addition and subtraction and work upwards. And the reason being that when things are added or subtracted from the letter that we're doing, they're kind of more loosely attached. The connection is not as strong and they're easier to separate from each other. So that's the basis of it. So let's see how that works out. So I've got a minus 2b is equal to 6. I'm trying to make a by itself. The problem is that the negative 2b is beside the a, so I want to get rid of that. I can do that by adding 2b to both sides, so that means a is equal to 6 plus 2b, and that's done. Okay, that's all we had to do. We needed to get that negative 2b away from the a. The second question, p is equal to m divided by j, and we want to get m by itself. The problem here is that the j is tightly attached to the m because it's dividing into the m. If it's dividing in and we want it to be gone, then the opposite of dividing is multiplying. So I'm going to multiply both sides by j. So what I have here, these two j's will cancel and I'll just be left with m, and on the left I have pj. So p times j is equal to m. That's done. The m is by itself on one side and it equals p times j. Question 3, 3c plus b is equal to a, and I'm trying to get c by itself. So c is here with the 3. Okay, so we're going to have to deal with that 3 at some stage because I need to get 1c. But the b is also there on that side and I want it gone. It's further away from the c. It's not as tightly attached, so I can deal with it by subtracting b from both sides. 3c is equal to a minus b. Now I need to deal with the 3. I want 3c to become 1c. How do I do that? I divide both sides by 3. Because don't forget, whatever I do to one side, I have to do to the other side. So c is equal to a minus b over 3. That's done. Question 4. 2p plus 3q is equal to r, and I'm trying to get p by itself. So again, let's look and see what's on the same side as p. The 2p is there, and the 3q, and then we've got an r. The 2 by the p is the last thing we're going to move because it's the most tightly attached. The 3q isn't really tightly attached at all. I'm going to subtract 3q from both sides. So what I have is 2p is equal to r minus 3q, because they cancel out, don't they? So now I'm going to divide by 2. And I'm going to have p is equal to r minus 3q divided by 2. Do you notice that 2 is dividing into that whole side? So I almost treat this like it's one unit. And I keep it as one unit and divide by 2 in that way. And that's done. Question 5. 3a minus 4b is equal to 2c. So the b is what I'm going to get by itself. Now, looking at this, hopefully you're thinking, what's going to be the first thing I'm going to get rid of? Yep, that's right. I'm going to get rid of the 3a. So I'm going to subtract 3a. So I have minus 4b is equal to 2c minus 3a. Now that minus 4b is connected that minus 4 is connected very strongly to the b. It's tightly packed because it's multiplying. And you need to take care here, because when something's multiplying by a negative number, we get a bit confused about whether it's subtracting or it's multiplying. It's multiplying here. It's minus 4 times b, not minus 4 plus b. So to get rid of that negative 4, I have to divide both sides by negative 4. So what I have is b is equal to 2c minus 3a divided by negative 4. And you see, when I divided, the 4 didn't change its sign because I'm not changing it from subtracting to adding. I'm changing it from multiplying to dividing. And that's that. Okay, so we're flying through these. If you need to take a break now and maybe try the next few, do. Okay, there's the next few questions if you want to pause the video and try them. Okay, I'm going to go up here now and work on question 6. So question 6 was x is equal to y minus 2z over 3, and I'm trying to get z by itself. Okay, I'm trying to get z. This is very messy because look, I have a 3, a y and a 2. So let's just take it slowly. So taking things slowly is a good idea in these. The first thing I'm going to do is deal with the 3, because if you notice, the y is divided by the 3 and the 2z is divided by the 3. So it's really causing a mess. So I'm going to multiply both sides by 3 to get rid of that. So 3x is equal to y minus 2z. Now that's looking nicer already, isn't it? That negative 2z is causing a problem. So I'm going to add, no, I'm not going to add 2z because I want z by itself. I'm going to subtract y from both sides. So 3x minus y is equal to negative 2z. Okay, now we're almost there. Look, we want to get z by itself. The problem is that negative 2, it's multiplying by the z, so I'm going to divide by negative 2. So 3x minus y divided by negative 2 is equal to z. And that's done. So do you notice what we did there? We worked slowly. We worked step by step. If you try and do these things too quickly all in one go, you're going to make mistakes. Question 7. 2a plus 3, sorry, I have to lift this to write it down, is equal to ab plus c. That's going to be 7. 8 is going to be abc is equal to 5a minus b. Okay, and this one's going to be a, and this one's going to be a as well. Okay, sorry about that. Okay, so here we have 2a plus 3 is equal to ab plus c. Now this is a really tricky one. So this is tricky, and the reason it's tricky is because I've got a's in two different places. And I only want to end up with 1a equals everything. So that is going to cause me trouble. So how do I go about this? The first thing is I get all the terms that have an a to be on one side. So I'm going to take ab from there and ab from here. So I've got 2a minus ab plus 3 is equal to c. Next I'm going to get rid of that 3 because it's not doing anything with the a. 2a minus ab is equal to c minus 3. Now this is the trick. I have two a's and I want to go to 1a. How do I do that? I factorize. If I take the a as common, then I can rewrite this as a by 2 minus b. I've gone from 2 a's to 1a. That's a really handy trick, and you really need to know it, especially if you're going to go on and do higher level at Leaving Cert, some of you junior cert students. Okay? Now, this is the whole thing. I need to move all of this away from the a. I can move it as 1 unit. I've kept it in a bracket. It's 1 unit in that whole bracket. So it's multiplying by the a at present. So I'm going to divide by 2 minus b. So a is equal to c minus 3 over 2 minus b. Or I could just say a is equal to c minus 3 over 2 minus b. So that's a tricky one. That's the trickiest one yet. Go back over it if you need to. Okay, same thing again here though. So you might want to pause the video and try this one and then see what I do. Okay, so let's see. A, we want to get all the terms with a on one side. So let's subtract 5a from there, subtract 5a from there. abc minus 5a is equal to minus b. The next thing we're going to do is to factorize. It's this trick. I want to go from 2 lots of a to 1 lot of a. So a by bc minus 5 is equal to minus b. Now look, We're nearly there. Divide by BC minus 5. Divide by BC minus 5. I can move it all. It's 1 unit is multiplying by the A. So my A is equal to minus B divided BC minus 5. Okay? So that's tricky. Those ones are tricky. But once you've done one or two of them, they definitely get easier. Okay, question 9. X is equal to y by y minus x. Okay, a couple of different ways we can do this. We'll try it a neater way and then a messier way. So what I'm going to do, x is by itself. How I'm going to do this is I'm going to multiply out my bracket, y squared minus xy, because the brackets are just messy. Okay, what am I going to do next? I'm going to rearrange it so that I've got x's, all my x's together on one side. So I'm going to add xy. That was that by that. And I'm going to add xy. So x plus xy is equal to y squared. Now both my terms with x's in them are on the same side. Now I can factorize. X by 1 plus y is equal to y squared. X by 1 would give me x, x by y would give me xy. Now I'm going to divide by 1 plus y. Divide by 1 plus y, because that's 1 unit. I can divide by it. X is equal to y squared over 1 plus y. Nasty, but it's doable. Let's try that a slightly different way in case you want to try it this way. So I can divide by y to start with, to get rid of that y. So I have x over y is equal to y minus x. But you see the problem here? I've now got a fraction. Now I can still deal with it. I want everything with an x on one side, so I'm going to add x here. So I've got x plus x over y is equal to y. Okay, this definitely doesn't look as nice as the other one, but I'll keep going. If I factorize this, I'm going to have x by 1 plus 1 over y is equal to y. And now look what I end up with. I end up with x is equal to, so I divide by 1 plus 1 over y, divide by 1 plus 1 over y. So what I end up with is x is equal to y divided by 1 plus 1 over y, which is really messy. I could multiply then across by y, but anyway. So you can see there that by dealing with the bracket first of all, up here, it actually made it much easier. This is much messier. These are actually the same thing. This is the same as y squared over y plus 1. But the thing is that it was much harder to get to there. This is much nicer. That was 9. Okay, 10. 10 is y is equal to x plus 5 over 4. And I'm trying to get x by itself. But this is an easy one. How did this get in here? I'm going to multiply both sides by 4. 4y is equal to x plus 5. And now I'm going to subtract 5 from both sides. So 4y minus 5 is equal to x. That's fine. Okay, that's done. Question 11. 4y is equal to x over 3 minus 2. And I'm trying to get x by itself. So let's add 2 to both sides. 4y plus 2 is equal to x over 3. And then let's multiply both sides by 3. So 3 by 4y plus 2 is equal to x. And we could multiply that out just to make it neater. 12y plus 6 is equal to x. And that's that done. And finally, question 12. Y is equal to 4 by 3x minus 5 over 9. That's x. So the first thing I'm going to do is get rid of that 9 by multiplying both sides by 9. So 9y is equal to 4 by 3x minus 5. So 9y is equal to 12x minus 20. Add 20. I'm running out of space. 9y plus 20 is equal to 12x. Divide by 12. Divide by 12. 9y plus 20 over 12 is equal to x. And I can actually simplify that a little bit. If I divide everything... Oh, I can't. There's nothing that goes into all of those. So what I'm left with is 9y plus 20 over 12 is equal to x. Okay, hopefully that's helped. Talk to you soon. Bye.